Hello everyone, and welcome back to the Jamaican Geologist YouTube channel. This is episode 14 in the Geology Foundation series, and today we're diving into energy resources. So every flip of a light switch, every drive you make, every phone charge, you're tapping into Earth's energy resources. But where do these resources come from, and how does geology explain them? In this episode, we'll explore fossil fuels and renewable energy and the geology behind both. Fossil fuels and geology, that connection is obvious, but renewable energy, you might be surprised at just how much geology is involved in that too. Stick around and find out. So let's start with coal. Coal's story begins with vast prehistoric swamps filled with lots of vegetation. Over thousands of years, this plant material piled up and formed peat. And peat is a spongy, low-grade fuel, and it's the very first step toward coal. As the peat gets buried deeper, heat and pressure squeeze it into lignite. With even more burial, lignite transforms into subbituminous coal, then into bituminous coal, and finally, at the top of the coal ladder, we reach anthracite. And that's the hardest coal with the most carbon and the highest energy value. Each step along the way shows how geology slowly transforms simple plant material into one of the world's most powerful energy resources. Now, of course, coal is declining as we transition to cleaner energy sources. But I still think it's worth discussing because coal has been one of the most important fuels in human history, and its formation is a perfect example of how geology turns everyday materials into powerful resources. Okay, so now let's look at oil and natural gas. Unlike coal, which forms from land plants, these fuels mostly form from marine plankton, the microscopic life drifting in ancient seas. When plankton died, their remains settled on the seafloor, mixing with mud and creating organic rich sediments. Over millions of years, as these layers get buried deeper, heat and pressure slowly transform the organic matter into hydrocarbons, what we know as oil and gas. But that's only part of the story. Once formed, oil and gas don't just stay in one place. They migrate upward through porous rock. Remember, we talked about porosity in the last episode, moving until they hit reservoir rock where they can collect. And above that reservoir, impermeable layers called cap rock act like a lid, trapping the hydrocarbons in place and creating deposits that can be drilled and extracted. Today, oil and gas power much of the world, but geology reminds us they are the product of millions of years of Earth's processes. And it's a reminder of just how deeply our modern world depends on past geological activity. Now, let's switch gears to a different energy source, geothermal. Instead of relying on plants or plankton, geothermal energy taps directly into the Earth's internal heat. Deep beneath the surface, hot water and steam build up in reservoirs, sometimes several kilometers deep. To access this energy, wells are drilled to these reservoirs. They drill down into the reservoirs, and The steam rises through the wells and they spin turbines, which drive generators to produce electricity. In some systems, the heat can also be used directly for heating and cooling buildings. Geothermal energy shows us a different side of geology. The Earth itself is a power source with heat that has been building up over geological time and ready to be harnessed in ways that are clean, renewable, and sustainable. So, from geothermal, which taps into Earth's internal heat, we now turn to energy sources that rely on the sun and wind. So, you might wonder, what do solar and wind have to do with geology or extractive industries like mining? On the surface, renewables are clean and, of course, renewable. And they're designed to minimize our impact on the planet. Those of you who watch my channel regularly know where I'm going with this. Renewables are the future, and they're the path that we must take, right? But the catch is, most people don't realize how connected renewables are to the mining industry. Copper, lithium, lead, and even the glass for photovoltaic cells are all of them come from mining. And we can't yet recycle every bit of these metals at scale to make a fully circular economy globally. So if you're pro renewables, you're also, in a sense, pro mining, whether you realize it or you don't. Until we develop new technologies to produce metals cheaply and sustainably, mining will remain essential to meet the world's energy demands as we transition from fossil fuels. So why does this matter? Well, understanding where our energy comes from, coal, oil, natural gas, geothermal, solar, and wind, is more than just an academic exercise. It's about understanding how humans interact with the earth, how geology shapes our daily lives, and how every choice we make about energy impacts the planet. Even renewable energy, which is clean, still relies on minerals and metals mined from the earth. Fossil fuels may have powered the industrial age, but they also contribute to climate change. So, geothermal and other renewable options show us alternative paths, but they too are tied to Earth's resources. And knowing this helps us to make smarter decisions as we transition to a more sustainable future. So, energy is everywhere in our lives, from the electricity that lights our homes to the fuels that power our cars, and geology is at the heart of it all. By looking at coal, oil, and gas, geothermal energy, and renewables, we see a story that spans geological time and reaches into our modern world. Understanding this helps us to appreciate both the incredible resources the earth provides and the responsibility we have to use them wisely. So, in our next episode, now we'll explore geophysical hazards like earthquakes, volcanoes, landslides, and tsunamis. Thanks for watching and see you in the next one. So, take care.